Hello, welcome to this webinar on Advanced Steel Frequently Asked Questions. My name's Alec Giles. I'm a structures consultant at Greytech UK, and I'm also an Autodesk Expert Elite. I originally trained as a mechanical design engineer around 30 years ago, and I was a member of the Institution of Engineering Designers up until 2010. I spent around 10 years designing machinery, primarily for the steel and aluminium industries, and then I moved sideways to become the CAD manager for that company, and I was training and supporting around 200 users of AutoCAD, AutoCAD Mechanical, Inventor, and Solid Edge. But in February 2010, I moved to Graitec, and since then I've focused 100% on Advanced Steel, doing user support, training, sales demos, consultancy, and so on. So overall, I have around 20 years experience in support, training, and consultancy. Why should you choose Graitec as your business partner? Well, we're unique in the industry of being able to offer products across the entire life cycle of your designs and products. We split that down into 4 areas. First, we have Graitec Create, where you do all your design work using Autodesk products, and those are enhanced with power packs from Advanced Steel, from Graitec. We have power packs for Advanced Steel, for Revit, for Inventor, and for Volt, which add extra bells and whistles to each of those products. Once you've got your basic design, you need to prove it's going to work in the real world. So you can use simulation tools using the Graitec's market-leading and state-of-the-art simulation tools to do the FEM analysis on that structure. Once you've got your finished design, you need to manufacture it. So we move into Graitec Fabricate. And with that, we have tools there that can manage and control and schedule your entire workshop. That includes everything from feeding the right NC file to the right machine, and right through to scheduling and to assigning work and scheduling your human resources, your welders, and so on. And all of that work's going to create a hell of a lot of data and documents. So we have Graitec Manage, where we have tools to control and manage all your work in progress data throughout its life cycle, and protecting your IP and controlling that, make sure everything's on the latest versions and so on, right up to the point where it leaves your company and goes to an external company or a common data environment. Okay. All the webinars we offer are always recorded, and they're stored or posted up later on the Graitec Content Center. So we have content centers for AEC, for mechanical, and for structures, and those webinars will cover everything from industry workflows, best practice, tips and tricks, and so on. So you can always watch any webinars you've missed by going to the relevant content center. So you want to go to the Advanced Steel Content Center. There's over 50 of our webinars on there to watch. But we don't just do the content center we've just talked about, where you can get all the Advanced Steel webinars. Do you get the Advanced Steel blogs? We regularly post blogs giving bite-sized chunks of information for tips and tricks and hints, and maybe just some fun stuff here and there for Advanced Steel. There's over 100 of those available if you go to our blog site. Did you attend our user day in September? If you missed that, or if you missed the BIM Up conference last year or this year, those have all been recorded, and the videos of those are all available on demand at the Graitec Advantage website. So if you're a Graitec customer, you should have an Advantage login. Talk to your local Graitec office if you can't find your Advantage login. But once you've logged in, you can access the videos of all those classes. And if you're a Graitec support customer, you should also have access to the Advanced Steel Power Pack. So if you're in the UK, talk to the UK office. If you're in another office, talk to your local office. If you're outside the UK, if you don't have the Power Pack installed. But the Power Pack, as we've already said, is a lot of extra tools and bells and whistles to go on top of Advanced Steel to simplify some tasks that are commonly requested. This particular webinar today, what's it all about? Well, it's frequently asked questions, so we have a number we're going to go through. First of all, we're going to look at editing the palettes for drawing processes and bills of materials. Then we're going to look at using level symbols on drawings, some information about importing IVC files and common issues. Why are sometimes you got lines missing on your GA drawings or 3D views? And similarly, but slightly different, why are special parts sometimes missing on the GAs or 3D views? And then if you have any custom data on your machine, how does everyone else get to see that same model correctly? when you've edited your prototypes, why isn't it up to date? When you use that file later on, it's not showing the correct information. And finally, we've got sharing your model with other people who don't have advanced steel. So there's plenty of material there to go through. Let's get on with it. First up, we have editing the quick documents palette. So I mean, there's two of those. There's first of all, you've got drawing processes, then you've got bills of materials. There is the drawing styles, but we don't really use that one. So when you first install Advanced Steel, those palettes have a lot of choices on there. You can see it's got a massive list of different bills of materials or a great long list of different drawing processes. But the chances are you only really use a handful of those, 4 or 5 bills of materials, 1 or 2 different processes. It is actually possible to make it so the system only shows the ones you're interested in and doesn't bother showing you all the ones you never use. So how do we do that? Well, let's start with the Drawing Processes palette. First of all, go to the Output ribbon, Document Manager panel, and click on Drawing Process Manager. There's the icon. And then navigate through or select the Advanced or the User section, and then select the actual category of processes you want: assemblies, cameras, cold rolled, and parts. You should go through each of them in turn. The superseded doesn't really have anything in there we need to show. And then you can see that on the right hand side of the palette you get these tick boxes in front of each name. So you only tick the ones you want to see on the palette. Take out all the other ticks. So I've only got 1, 2, 3, 4, 5 ticked. I'll only have 5 showing on the palette. Then of course you click OK. Slightly different for the BOM templates palette. So for this one, first thing you need to do is go to the Output ribbon, Document Manager panel. But this time click on BOM Editor at the top right of that panel. And that will bring up a whole new interface in a separate window. And at the top right of that, you've got the folder structure. You need to go to Advanced or to User. And then you choose either BOM or Derived Documents. It's the same under both. And then under those, you can choose Parts List, Structured List, or Derived Documents. And those should sound familiar because they're the 3 pages that are on the palette. So once you choose one of the folders, in this case Structured Lists, you can see that again we have the list of all the different templates and tick the ones you're interested in. So you don't bother ticking the ones you don't use. And then of course you click OK again. Once you've done that in the dialog boxes, you're not quite finished. You have to do something else. You have to make sure that all your palettes are properly closed, not just minimized to the title bar. They have to actually be closed. Then you have to close Advanced Steel and restart it. And when it restarts Advanced Steel, it will rebuild the palettes based on your settings. So now when you look at your palettes, you'll see it's gone from having these great long lists to just showing the 4 or 5 that we're interested in. And obviously when it's only showing the ones you're interested in, you can just work your way through each of those in turn, or you've only got a small list to find the one you're interested in on the processes. Much easier to see what's going on. Why have all the clutter of all the others? So that's a good thing to do, nice tip. Get yourself sorted on those. Next up, we've got the level symbols on drawings. So when you do your modeling, we keep telling everybody, and it's good practice, you should always put something in your structure at 0, 0, 0 on the world coordinates. Probably a base of a column or finished floor level or something. But you need to show elevation symbols in your drawings like the ones highlighted in yellow here. So how on earth do you get the right elevation symbols on your drawings? Well, first of all, putting the basic elevation symbol on is quite straightforward. On the Labels and Dimensions ribbon, you go to the Labels panel and click on Insert Level Symbol. Then you have to select the view, anywhere in the view. Then you select the point you want to dimension. And then you click to one side to put where the text needs to go. And you'll get the symbols up, much like shown in yellow here. But you'll notice they're showing the actual height in the model. So the finished floor level is at 0 and the platform's at 2.4 meters. These are not the elevations we want actually showing, so they're not the height above sea level. You don't get many buildings exactly at sea level. So how do you get the right height? Well, you have to set a datum. And you do this, well, first of all, you need to know what the datum needs to be. So identify a point in your structure where you know the correct desired elevation. So we're going to say the platform should be at 31 meters, 273 above sea level. Then you go to your model, not the drawings, you go into the model, and you go on the Home ribbon, Objects, panel level symbol. So it's this different icon, still called level symbol, but this is for models, not for drawings. You select that known point you've identified. So I'd select a point on the top of the platform. And then it will show you the properties, and it will give you a value saying absolute level. What you need to do is work out what the desired elevation minus the absolute level is. So 31,273 minus 2,400 equals 28,873. Then you switch to the global page and go to the datum level box, and you type in that answer you just calculated. And to prove you got it right, you go back to the absolute level page again and check that's saying the right number now, 31,273. So that's it. Now we've set a datum in the model. So having set one level symbol in the model and set one datum, all level symbols in the entire project share that same datum, whether in the model or in any drawings or anything else. Anything to do with levels, going to share that datum. So just update your drawing. You can either do that with update detail or you can do it in Document Manager. But now those level symbols you drew get recomputed and they're now showing the correct height. So we can see the top of the platform's at 31,273 as we wanted. So it's quite a nice little system. You just need the one reference point in the model and everything else follows through automatically. There is an alternative. Oh, of course, you can put the level symbol in the model before you do the drawings. You don't have to wait till after you've done the drawings. If you know you're doing finished floor level and your site datum says finished floor level is at 31,273, put that in at the start when you're doing your grids. You don't have to wait till the end. You still model it as 000 in the model. There is an alternative to using level symbols. You might like this style if you have a lot of them. What you can do, you can use a vertical dimension. It would look like this instead of having those little triangular symbols. If you like this idea, then you make a normal dimension, placing a vertical dimension. Then in the dimension properties, you change it to say level absolute as presentation. And then you tick the broken dimension line to remove that vertical line through those dimensions. And it will look like this, which I think looks pretty good on stair layouts and so on. If you're clever enough, you can even set that up in the drawing style as an automatic dimension then. But that's a topic for another day. We're not doing drawing styles on webinars. Too deep. Okay, so that's the level symbols. So our next topic then was some issues or common things encountered with IVC files. Well, a lot of customers receive models as IVC from third parties. A lot of companies seem to think BIM means IVC, so they always give you IVC files. You want to import that IVC file into your advanced steel model so that you can add extra details and work on it from there. But when you try and import it, oh no, you've just got an empty spot file. Nothing there at all. What is going on? Why is that happening? Well, there's a number of issues with IVC files, and I've actually done a full webinar just on that one subject, which is already on the Content Center. So if you want to know a lot more, go to the Content Center and watch the full webinar about IVC files. Why won't my IVC file import, I think it's called. But in summary, first major issue is that IVC files can have custom fields added into them. When exporting data from system to IVC, it can be quite hard to map your intelligent data into the correct IVC fields. So because it has this ability to create custom fields, a lot of software is quite lazy. So instead of trying to map it all through to the official fields, it just creates a load of custom fields and puts the data into those custom fields. And you can see here, this file has loads of special data from Tekla. But that data is completely and utterly useless to anyone importing that file. Only Tekla can understand the Tekla custom data. And if you're going from Tekla to Tekla, why would you use IVC? So that all those custom fields are basically a complete waste of time, shouldn't bother existing. The second bigger issue with IVCs is that IVCs can represent parts in two ways. They can represent them just as a pretty picture, called a boundary representation or BREP, or they can represent it as intelligent solids. Again, it's often quite difficult to translate your model into intelligent solids, into the official fields for that type of object. or there might not be official fields for that type of object. So again, a lot of software, when it exports, takes the easy option. It just describes it as a pretty picture and makes it look nice in the file. You can see here, this file, nice bit of stair and railing there. You think, oh no, I want to import that and add some proper nuts and bolts and stuff in there. But you can clearly see here it says geometry, boundary representation. Boundary representations, or BREPs, cannot be imported as an intelligent object that you can edit. If they import at all, they'll only be imported as solids. Critically, Advanced Steel cannot import a BREP at all. You won't even get a solid, you'll get absolutely nothing. So in this picture here, this looks like a very nice building. Got some nice stairs and railings. You think lots of steelwork there I want to enhance and add detail to and draw. You won't get anything at all importing that file because it's all BREPs. You'll just get a blank file. There's nothing you can do about it at import time. This is when the file is exported from the source software. So most source software takes the easy option and just puts a lot of custom fields in, or puts everything as BREPs. You can check for that if you want to. There's lots of free viewers available. For example, this top image with the showing the custom properties is taken from FZK viewer, and the bottom image is taken from the Celibri viewer. Two very nice viewers that I would recommend free of charge. Just search the internet. So what on earth can you do then? How are you going to get anything useful? Well, there are several workflows where you can convert the IFC into just solids, that you can import the solids into your Advanced Steel file instead of intelligent objects. So like I say, they won't be intelligent. You can't just double click a beam and change its size. They'll just be solid blobs of the right shape and size. So editing them will be a nightmare, but at least you can put your neighboring steelwork or work around them and see what's going on, trace over them, or do whatever you need to do. So here's an image of something that's been imported through solids only into Advanced Steel. Depends which software you want to use to do this workflow. There's 3 different workflows I outline in the full webinar using different software. So you need to watch the full webinar to see what those 3 workflows are. And those workflows don't cost you anything. One of them might, if you haven't got the AEC collection. If you've got the AEC collection, then you've got Revit, so it doesn't cost you anything. If you haven't got the AEC collection, use one of the other 2 workflows instead, which are both free software. So that's your IFC files. Our next topic was why are sometimes getting lines missing in your general arrangements or 3D views. Here we go. We've got a model. Nice simple bit of model with a nice simple bit of railing in there. Get the drawing. Oh dear, what's going on here? Top rail's missing altogether. Got errors in the file. Well, what's going on? The cause is you have clashes in your model. So when you got clashes in your model, Advanced Steel is following the edge and trying to work out what to show. It gets a clash. It can't. Basically, the drawing engine just gets confused. Can't calculate whether to show the line or not show the line, or whether it's hidden detail or what's going on, and it can't calculate an accurate result. The cure is you must correct all the clashes in your model, and then the view will run correctly. Let's have a look at that in action. So here's the model that picture was taken from, and we've got various elements in there. You can see the railing there. We're just going to create a drawing from this camera. I'll just run the process. Okay, open up that drawing and have a look at what we got. You can probably already see, but let's zoom in down there. We've got the top rail missing. You can see it's got spaces there. So it's lost the plot. Can't tell what should be showing for that railing. So what's going wrong? Well, if we come into the model and do a clash check, I'll just clash check these few members to save time. Clarity, you can see that we have a clash between the rail and the ball. And that's because the rail tube is too fat. It's too big a diameter for the hole in the ball. So let's edit that railing joint. This is a railing placed with the PowerPack Premium ball post railing joint. So I'm just going to edit that joint, and we're going to go to the handrail and change the diameter of the tube. Okay, and then we'll double check and do another clash check on that area. No collisions found this time. So we're happy now. Go back to the drawing and update. There you go. It's drawn correctly now, no problem at all. So the errors are caused by clashes in the model. I will say one little caveat. The clash in this case, in this demo, was obviously associated with the railing that was missing, but it's not always the part that is drawn incorrectly that has the clash. You really need to fix all the clashes in your model. The only exception to that is clashes between anchors and concrete. We don't expect you to cut holes in the concrete around all your anchors. Any clashes on the anchors to concrete don't seem to cause an issue, but any other clashes in your model will potentially cause issues with the GA drawings, and it's not always the part with the clash that's got the problem in the drawing. So fix all other clashes in your model. Okay, a similar question though. Sometimes we get a special part. You've put in this nice special part in your model, but you can't see that in your drawings. What's going on there? Here's an example. Got this nice little joist hanger on in grey there on the hot rolled beam, but when you get to the drawing, it's missing. What's going on? Why is it missing? Clearly see it in the model. The cause of this is that the special part contains a block, or most likely the whole thing is a block within its original source file. When you import, if you import a step file, perhaps into a DWG, it often comes in as a single block rather than individual solids. The answer is to explode any blocks in the model and purge them from that DWG, not your parent structure model, the special part file. Inside that special part DWG, explode all blocks and purge them out of the model. And then back in your main model, you redefine that special part and you update the drawing. So let's see a sample of that. Here we go with the model again, similar model. We're going to go and insert a special part somewhere down on this beam. Make sure I'm in world coordinates. So let's put it somewhere on the top of this beam. Get the snap right, there we go. Right. We browse the special part on disk. So select the joist hanger. There you go. One little tidbit. You should put whatever you want to see on the bill of materials should be placed in the commodity number property. Whatever you write in there is the actual description that will go on the bill of materials. And the correct model role is ASYS object. So there we go. We've got our special part in the model. We'll create a camera drawing. I'll just go to the camera drawing. There's already one there. And we better update that to see what happens. So there we go. Update the view. See if it shows. Let's have a look. No. So we've just updated the view, but our special part is still missing. What's going on there then? You can clearly see it in the model. Well, we need to open that special part file. There it is. Here's the file with the part in it, and we can have a look at what's going on. So if you hover over it, you can see it says in the tooltip, block reference. If you select it and go to AutoCAD properties, you can see at the top there it says block reference. So this is a block inside this file. If you ever have that, Advanced Steel can't do anything useful with it. You must not have blocks. So we're going to explode, select the part, and accept. There you go. Now when you select anything and check the properties, it's just a 3D solid. That's what we should have, not blocks. We only want 3D solids. So now we're going to purge out all the blocks in the file just to make sure they're well clear. Nothing confusing anything there. And we can save that file and close it. So we've taken away all blocks in that file. We just have 3D solids. Now back in our model, we need to select our special part and update the definition. So you go into the properties and we browse again to the file on disk. When you do that, say it already exists. Do you want to overwrite it? Yes, you do. So that's updated the definition in the model, and now we can update our view in the drawing. And there you go, the special part is showing correctly. So the reason special parts might be missing in your GA drawings is because they are blocks. You must not have blocks inside the special part file. You should only have 3D solids. Okay, so seeing your custom data on other PCs, what's that about? Well, you might have in your model some special beams or other properties. So looking at this picture, you can see we've got some custom beams here for the freestanding glass, the concealed channel and the wedges. There we go, that's in the model there. It's fine on your screen, but when you pass it to somebody else and they open it on their computer, they just get these weird placeholders, these funny little triangles. They can't see what's going on. Well, that is because your model has custom data in it. Your machine knows about these beams and knows what they are. Other people's machines don't have a clue. This doesn't have to be just user sections. It could be materials or coatings or model roles that you've added to your system, or bolts or whatever that are not on someone else's system. So how can you make it so these other people can load up your model and see it accurately? Well, the key is you need to go to the Tools ribbon and click Store Used Data. So in your model, go to Store Used Data and click that button, then save the model, and it will be fine. So let's have a look at that. Here's the architectural model we used for the example. And we can zoom in here and you can see we've got these custom beams. Let's show that in the so Q rail, bottom rail, so there's this custom user section. Change it to exact, you can see the fancy shape. That won't exist on the standard build on anyone else's machine. We've also got another one for the handrail at the top there. I've also put in a custom coating here on this stringer, rail color, plastic coated, powder coated. So we've got other custom properties in this file as well. Now that's fine, it looks wonderful on my machine, but if we give that to a third party or another person, it may not look the same. So I'm going to save that and I'm going to go close Advanced Steel and switch to a build. So this is now a clean build, an out of the box build. We obviously have to edit that, so change the data set around. But this is now, if you loaded this on another machine which doesn't have your custom data, this is what you're going to get. So opening up the file, looks right from a distance, I suppose. But then you start to look a bit closer. And something funny going on down here. You can see those beams are missing. All you have is these triangular placeholders. Advanced Steel doesn't understand what that beam is. In fact, the beam name is blank because it doesn't even recognize the name of the beam. Same for the top rail and the wedges. If I go to the coating on this stringer, again, the coating property is just blank. All that custom information has been lost. Advanced Steel doesn't know what to do with it on this machine. It's all nonsense. So what are we going to do to cure that? Well, let's come out of that version and go back to the build that had our custom data in. So this is our file on the machine with the custom data. And we go to Tools and we click on the Store Used Data button. And that finds all the custom data it thinks it needs and adds it into this file. And it gives you a list on the command line of all the data it's added in. In fact, there's a lot more there than I would think might be necessary, but nothing worth questioning. It's putting all sorts of things that possibly might not be on the other person's machine. So we've saved this model again, having stored the used data, and we'll open that on the other machine with the out-of-the-box build. You see it's out of the box. It's even asking what language I want. So we'll open up the same file, having stored the data in that file on our machine. And we'll already probably tell from here, but we'll have a closer look when it finishes loading. There we go. We've got the same custom beam that we had in our file. Double click on it. The beam name is known. And if you go to the stringer, the custom coating is there as well. So store use data means that anybody else opening that file will get all the custom information. It's all embedded inside that model. This is a common thing we find on support as well. People are sending us models to say what's going on with my model here or these beams there, and we can't see the beams because they're custom beams. We just get these silly triangles. So don't forget, when you send it to us on support, if you even suspect you might have used some custom data, do that store use data before you send us the model, because otherwise we can't really tell what's going on. It's just going to delay your support call by another couple of hours, so we have to ask you to send us the file and remind you to click that button and so on. So anyone who uses custom sections or materials or coatings, before you give it to anybody else, is worth clicking on that store use data button. Right. Next topic. Sometimes you edit your prototypes and the changes don't seem to show up properly when you use them later. This is, you've opened your prototype, you've edited the title block. We're really talking about things in the title block here that don't quite show correctly when you load to the other machine. And this is down to the attributes in the title block. AutoCAD is a bit quirky when you edit attributes. You can edit the attributes and it all looks great, but it actually doesn't update the attributes in the block when you finish the work. It knows what you've changed, but it doesn't seem to apply it. What you need to do is an extra command not a lot of people know about. It seems to be a bit of a little known command, which is @sync attribute synchronize. You have to type that command in, use it on the title block hyperstill page header, and that will tell AutoCAD, okay, now update the attributes to match what I've defined now instead of the old definition. Don't quite understand why they do that, but they do. A lot of people think you have to explode the block and redefine it from scratch. You don't. You can edit it as long as you use the @sync afterwards. That command will update all instances of the block to bring up the latest version of the attributes. And then you can save your prototype and you'll be fine when you run drawings from it in future. So let's have another quick look at that. So I'm going to go to edit prototypes. Let's go for GAA1. We'll just do some simple changes to the title block. So we'll go block edit. And to begin with, I'll make an obvious change. I'll change all these yellow labels. And let's change the color of them. So I'll make those magenta. Now I'm trying to do the same with the green text. I don't want the green text to be green, so I'll change that to cyan. Oh, missed one. Okay. I'm also going to do a simple thing. I'm going to just swap the scale and the date over. So let's move the scale out of the way. Put the drawn date over there, and now move the date scale back in to the empty box. So there you go, some simple changes to the title block. I'm going to save and close the title block, and I'm going to save and close the prototype. Right, now I'll make a quick drawing. So just grab a camera and run the process. I'll insist it goes on the A1 sheet, so I've done the A1 process. And then we can go straight to the camera drawing. Remember, you can do that with a right click. You have to go through Document Manager. Load up the drawing. I'm not interested in what the drawing shows, but if we zoom into the title block, you can see all the labels have gone magenta as we asked for. Bang about, all that green text is still green. It's funny. And the scale and the date, well, the date it's still in the box saying scale. So what's going on there? It hasn't really updated correctly. And that's because all that green text is attributes. So we'll drop that. We'll go back into the prototype. Because all that green text is attributes, we need to run that extra command on the title block. Once it finishes loading. So type in @sync, ATTSYNC. We'll say we'll select. You pick the title block and agree. And you can see now that, as noted, jumped to the white box and changed color. So that's a good sign. We can save and close the file again. Run another new drawing from that template prototype. Now we've corrected it. Go into the drawing. And now we can have a look at the title block again. When it gives me control, come on. And now we can see that all the attributes have gone blue and the scale and the date are the right way around. So remember to run that @sync command whenever you do anything with the attributes inside the title block. Final topic for today. How do you share your model with people who don't have advanced steel? Well, there's several things you can do. If your third party has AutoCAD higher than version 2015, then they could install the object enabler on their system, and that will enable them to see the model. But it has to be the same version as your model. You could send them an IFC file, and they could use a free IFC viewer to view that file. Or you could export your model to a DWF, which can be viewed in Navisworks or Design Review. Or if they want to send them the original model and they have the object enabler with Drawing True View, they could try that, and that would also enable them to see the model. But all of those require the customer to install special software to view your model, and they're usually too reluctant to do that, and their IT might be outsourced and they might be locked down. They might not even be able to install the software even if they were willing. So that's a lot of aggravation and can be a bit of a faff. So is there a better alternative? Well, yes, there is. Basically, you can go to the Autodesk Online Viewer. So the web address for that, if you just want to type it in instead of clicking on these links, is just viewer.autodesk.com. So Autodesk Online Viewer. And then you can provide a link to that file in the viewer to anybody you like, and anybody with that link can see your model inside their web browser. You can even see it on a tablet or a smartphone. It's that good. There's no special software to install. We do recommend that you tidy up your model a bit before you send it or upload it. So turn off all the joint boxes, turn off all the cameras, click the store use data command so any custom sections things are known, hide all your beam and plate features, all that sort of stuff. Tidy it up so it's a nice clean view before you upload it, because they can't do any of that in the viewer. Then you go to the web page for the online viewer and log in, and you upload your file. You can then generate a link from there and share that link with anyone you like, and anyone with that link can see that file in their viewer without an Autodesk account. They don't need anything special to see it. They can see it, they can view it, they can measure. If they do have an Autodesk account, they can also redline and mark up that file. So they can put comments on there, they can put balloons around things, and when they do that and save it, you'll get an email saying they've commented and you can review their comments. They're great for customer approval. But they do need an account for that. But the Autodesk account is free to anybody. You don't even have to pay for any Autodesk software to get an account. Anyone can set up a free Autodesk account. So let's have a look at some of that in action then. Oh, the files that you upload stay online for 30 days. After 30 days, they automatically delete the file. But if you wanted it for more than 30 days, you do get a warning before it's deleted, and you can click a button or a link to tell it to extend that time for another 30 days. Okay, so let's see that in action. Here's our model, a bit messy, got all the joint boxes and things showing. So let's clean up this model before we do anything else. So let's hide all the joint boxes. Let's turn off all the cameras. Like I say, you could also turn off things like plate features and things. We're going to select the bolts. We're going to make sure they're shown as solid. So go into their display type and check they're as solid. Also do the same for anchors and make sure they're displayed as solids. Okay, so now everything should show nicely. Yeah, we can see the bolts there. To clear it up, make sure what you get on your screen here is what you want the third party to get on their screen, really. Save that. Right, now we go to our web browser. I'll search through so you can see how to search for it, but it is, so I'm just going to search for Autodesk Online Viewer. First thing is all viewers for Autodesk. Okay, that'll do. What have we got in there? Well, we don't want all these different things you can download, but as you can see there, there's a link for the online viewer, so we can go through that. But as you can see at the top line there, the actual address to go straight there is just viewer.autodesk.com. So I'm going to upload a file, so I need to sign in with our account. So log in there. And now we're in there. We can upload our file we want. So click the upload new file button, find your file in Explorer and just drag it onto the screen, and then so no more files, so just it's uploading now. Now it does have to upload the file, so that will take a few seconds depending on the internet and how big the file is, and then it's processing it. So it has to analyze the file and decide how to display it. It's got things it has to do in the background on the servers online. This isn't your computer. You can go off and do something else and just leave this page open. It will email you when the file's ready to be viewed, but we can just wait. It doesn't take too long, depending on the file size, of course. This will only take a few moments. Okay, it's nearly there. Once it's finished and it comes up, you can switch to the 3D view. Remember, this is all in the browser. There's no special software on my machine. That's what it looks like when you get into the 3D view. Rather nice. You can rotate, zoom around. You can switch to a first-person view, and you can walk around and do slightly different zooming methods. So move about, get different perspectives on things. You can go inside if you're using the first person, but it's a little bit more tricky to use. If you select a member, you can click on properties at the top left there, and here's all of the advanced steel properties. So you've got things like colors and layers. You've got the beam size, the coatings, the material, the part numbers. You got R1, M4, and so on. Same for bolts. If you scroll through there, you've got what type of bolt it is, what type of holes you've got, everything else. Then you can let's go back to the home view so we know what we're looking at. You've got a model browser here. You can browse through the individual components, but they can tend to have cryptic names. You can select an object here and you can hide it or isolate it, so you can see things more clearly. You can do sections through the model. You can't even do this in advanced steel, but there you go. You've got section plane. You can play with these grips to manipulate this section plane. Let's try a different one. It's a bit better. You can even rotate these planes to any angle you like. You can't do sections through the model like this in advanced steel, so that's quite cool. Turn that off. You can do this thing called explode, which if you scale this value up high enough, it moves apart all the objects, so you can see the individual objects if you want to. And you can measure. So there's the measure button. So you've got all the normal snaps you would expect to have. So you go maybe from the midpoint of that flange and you can choose another point. Let's just go anywhere, and you can see it gives you the X, Y, and Z directions as well as the shortest possible distance. And like I say, if you were logged in, you would also be able to mark up as well. At the top right, you've got the share button, and you can copy the link it creates there. And you can email that link to anybody you like then, or send it to anybody in any means you wish. But with that link, anybody can open that file and do exactly what we just did without any CAD knowledge and without any special software. You also get this email once it's finished uploading and processing the file, so that's you don't have to wait and watch it when it's doing that. So we're now going to just prove someone else can use it. We log into the web browser as a private session, so it's you can see it saying sign in at the top, so we're not logged in as anybody, but I can still open up that 3D view and see everything and do everything that we just did. And that's saying sign in, so you can tell I'm not actually signed in. So it's a very good viewer. It's a native advanced steel file. You haven't got to export or do anything special. We do recommend you clean up the display before you export, before you save it, and anybody can view it. So that's a really nice system. So that's basically all my waffling done. One thing I should say is if you look at the GoToWebinar interface, this presentation is available as a download there as a handout. So go into the handouts panel, click on the presentation if you haven't already to download this presentation as a PDF. It's been a bit of a whistle-stop tour together, so you'll have a chance to review those slides and review what we've said to fix any issues you might have. And you'll also be able to use any other links. All the links in there will be live on the PDF, so you can just click them to go to the right places. So if you haven't already done so, download the handout from the GoToWebinar panel. But we can now give you a few moments to ask any questions. If you have a question, type it into the GoToWebinar question box. Okay, so there don't seem to be any questions forthcoming. As I say, all webinars are recorded, so this webinar will be posted on the Content Center shortly, in a few days. So you can review it live or download the handout, and you can browse through the slides yourself at your leisure. So thanks very much for your attention. I hope you found it interesting and useful.